Good morning, everyone. We are in day one of distance learning, and we are going to start with the review of chapter 19. We covered all of this information before spring break, but I think that it will be a very good idea to review it and practice on it before we take any sort of test. So we will start with writing formulas. So the big thing to remember with writing formulas is that you need to know the element symbols, you need to know the polyatomic formulas. We've worked on the element symbols. You have the polyatomic formulas written in your notes, but I did list page numbers for you if you still need some help with that. So make sure that you use your book. You also need to know oxidation numbers for the elements in those polyatomics. The elements, we marked their oxidation numbers on the periodic table. So if you have yours, that would be the best thing. But again, there is a chart in your book that has the most common oxidation numbers. So use that if needed. And in your notes, and also again in the book, the oxidation numbers for the polyatomics are there. The big thing with knowing those oxidation numbers is using them to make sure that the positive and the negative equal 0. Remember, that's what we're doing with these, and that's the important part of figuring out subscripts, of figuring out how many of each element that you need. All right, so a couple of tips as far as getting started on writing these formulas. Big thing, or one of the big things, is to look at the endings. If you have an "ide" ending, you will most likely have 2 elements in your compound. There are exceptions, but that's kind of the general rule. And if you have an "ate" ending, then you will have 3 or more elements. Definitely will have a polyatomic in there at this point. So with that being said, our examples, we have calcium oxide, "ide" ending, so we've got 2 elements that we are dealing with. Calcium is Ca, and it has a +2 oxidation number. It's an alkaline earth metal. Everything in that column has a +2 oxidation. Oxide is O with a -2. Now those two already equal 0, and so I don't need to add subscripts. I just write the formula. So I have a Ca, whoops, sorry about that, a CaO. And those two equal 0. Sorry, I'm going to get better about writing on here. And that's your formula. Now this next one, sodium phosphate, 8 ending, that means that you have a polyatomic. So starting with our sodium, sodium is Na. It is in the first column, which means that it is a +1 oxidation number, an alkali metal. The phosphate has the formula of PO4, and its oxidation number is -3. So now they don't equal 0 automatically. This is where I have to add subscripts. So I will need 3 NAs. So I would have Na3, whoops, and PO4. So that's like saying +1 +1 +1 -3, and that equals 0, which is our goal. Now remember, just another little kind of a reminder, if you have a polyatomic, it can be useful to you or helpful to you to put parentheses around it, just so you kind of set it apart. All right, moving on. Okay, our next section is naming compounds. So on this one, we have the formulas already, and we are going to be writing the actual words. So again, use your periodic table if you don't know the names of all of the elements, the one in your book. Look in your notes for the polyatomics if you use those, and just do your best as far as spelling goes. So when you are naming compounds, big question, how many elements are you dealing with? Is it 2 or more? If it is 2, you need to then ask yourself, where are those 2 elements? Are they on opposite sides of the periodic table? So is one over here, whoops, is one over, oh my goodness, sorry, I can't get my pen to work. Is one over on this side or this side? So those are opposites. Or do you have different elements that are right close together on the same side of the periodic table. So are they two nonmetals that are together? And that will make a difference as far as if you will need to use prefixes or not. All right, so now if you have elements on opposite sides, this will be probably the easier ones to name because you don't really have to add anything extra except the ending. So the first element you name as normal, whatever it is, you just write that name down. The second element, you will change the ending to IDE. So there's that IDE ending. We've already talked about that a little bit. So our example is magnesium bromide, MgBr2. So the magnesium, the Mg is just like normal. It is magnesium. So you would have magnesium. And then for the Br is bromine. You change the ending to ide. So you would have magnesium bromide. And that is it. You don't have to worry about that little 2 in the formula. You don't have to worry about any of the numbers. You're simply dealing with the elements themselves. All right. Now, if the two elements are on the same side, you have two nonmetals. This is very often called a covalent compound. You would name the first element just like normal and add a prefix. So here are those prefixes that we listed in your notes somewhere. The prefix is there to tell you how many. So now the numbers do matter if they are in your formula. The prefixes are similar to what you've learned in math. Mono is 1, di is 2, tri is 3, tetra is 4, penta 5, hexa 6. You guys know those. If you don't, look in your book, look in your notes, they're there. But you use that prefix to tell how many. For the second element, same thing, you add a prefix for the number and you change the ending to ide. So there is our ide ending. All right, now our example, NF3, I have one N. N is nitrogen, I have one of them, so I'm going to go ahead and put mono nitrogen. The mono on the first element is kind of optional. It's not wrong to put it, but it's just not as common, so you may not see that. I will never count that wrong. So if you want to put the mono, put the mono. As long as it's on the first element, it is optional. Any other prefix, it would have to be there. Now for our second element, we have F, and we have 3 of them. So the prefix for 3 is tri, and F is fluorine. It becomes fluoride. I can't cross my T. Fluoride. And that's it. These are the 2 element symbols. Now, if you are dealing with 3 or more elements, this means that you have a polyatomic. So depending on where the polyatomic is in the formula, it may kind of change how you're going to name stuff. So our example, if the polyatomic is second in the formula, so you have Na, and then the NO3 is the polyatomic. I don't have parentheses around it, but remember if you put that, it will kind of set it apart when you're writing the formulas. So for NaNO3, Na is sodium. So I just name that as normal, nothing changes, no prefixes. And then same thing with the polyatomic. I don't have to change any endings. I just put what it is, and NO3 is nitrate. Okay, now if the polyatomic comes first, so NH4, here's our NH4. It's the only polyatomic that we're going to deal with that will be the first element, and NH4 is ammonium. Let me write that where you guys can see it, hopefully. Ammonium. And then it is in a compound with Br. Br is bromine. You do change the ending to ide. This is that exception to the ide ending, meaning there are only 2 elements. So it's one of those things you just have to kind of work to remember. All right, so that is naming elements. All right, balancing. When you are balancing, the main thing that you are doing is attempting to make sure that the elements are equal on both sides of the equation. Think of the arrow sign as an equal symbol, and you just kind of go back and forth. It's just like taking tally marks of what's on one side and making sure it's the same on the other. One thing to remember, those little subscripts, the little numbers that are after the element symbols, only apply to the element that they follow. They only deal with what they are directly behind. If you have a number in front of the compound, so like our SO3 over, or excuse me, our SO2 over here, if it has a 3 in front of it, that 3 goes to the S and the O, and you multiply any subscripts. So I have, in that situation with this 3 SO2, I have 3 S's, because 3 times the 1 S is 3, and then I have 6 O's, because 3 times the 2 O's would equal to 6. Okay, so now a real kind of an easy balancing, you just, again, like I said, go back and forth. So starting with my N2 on the beginning, I have 2 N's there. On the other side, I have 1. So I would put a 2 to make sure that my N's are equal. So I've got 2 N's and 2 N's. So N's are good. So now I would move on to my H's. H's over here, I have 2, and over here, because I put that 2 in front, I would multiply it, and 2 times the 3 is 6. So that means I have 6 H's on this side total. Over on the other side, I need 6 also, so that means I need to put another 3 so that I have 6 H's on both sides. The blank in front of the N, this first N, if it is a blank, once everything is balanced, if you want to put a 1 in those blanks, you go for it. That way everything is filled in and you know you've checked it all. Okay, almost done. Now, putting all of this together is what we do when we actually write the equations. If you are given a word description, like a sentence describing a reaction, I would like for you to be able to write the equation from that. So it involves writing the formulas and balancing. So our example, you have sodium chloride and lithium phosphate combined to form sodium phosphate and lithium chloride. So you just start from the beginning. With your first compound, you have Na, it is a +1, and Cl, it is a -1. So that's it. That's sodium chloride. I don't add subscripts. It already equals 0, so we are good to go. The and just means plus. Plus lithium phosphate. Lithium is Li, and it is a +1, excuse me, and phosphate is PO4, and it is a -3. Now, I don't have a 0, or they don't equal 0, so this is where I add my subscript. I need 3 Li's. So now that will equal 0, and that is lithium phosphate. This combined to form is just a long way of saying arrow. So they combine to form sodium phosphate, Na. Remember, it's a +1. Phosphate, it's PO4 -3. So I'm going to need 3 of those NAs, just like I did on the other side with the lithium. And lithium is a +1. Chloride is a -1. So that's the equation. I'm going to go back real quick just so we kind of follow that rule and put parentheses around my polyatomics, and then I need to balance it. So to balance this thing, start at the beginning. I have an Na, one of them. I have 3 NAs on this side. So I'm going to come back over here and put a 3. So my NAs are good. Now my CLs, this 3 is going to apply to this CL. So I have 3 CLs on this side. Over on the other side, I just have 1. So I can't add to the formula itself. I can only put numbers in front at this point. So I have to put a 3 in front of the entire equation, or the entire formula. And now my CLs are good. Going back, Li, I have 3 of them here. And with the 3 I already added, I have 3 there. So that one is good. And then the last thing is my polyatomic. I have a PO4 here. I have 1 of them. There's no number outside the parentheses. And over here I have one of them because there's no number outside the parentheses, and we're good. Remember, you can go back and put a 1 in front of any compounds that didn't get a number to start with, and that is balancing after you have written the formula. All right, almost finished. Now, types of equations, there are 4 of them. First one, composition. Just like it sounds, you are putting 2 substances together to make one compound. I used letters instead of element symbols on this. That may make it a little clearer, hopefully. If not, just continue to look back at the notes that you already have. But for this one, A plus B equals, or yields, or produces AB. So 2 things make one. Decomposition is the exact opposite. One big compound breaks down into 2 smaller compounds. So AB breaks down into A plus B. Now the replacement equations. So single replacement, I will have a single element, that's this A, and it's going to trade places with something in the compound, in this case the B. So they just flip-flop, and so you will end up with the B by itself over here, and the A gets to be in the compound. Then double replacement, 2 elements from 2 different compounds trade places. So the AB and the plus CD, the A and the C in this case are what I have flipping, and so you will end up with the C combined over here with the B, and now the A will end up with the D. All right, those are the review notes for chapter 19.